So keep solving our physics GRE. Be sure to subscribe to my channel. Okay, so 39. Which of the following atom has lowest ionization potential? So it's the common sense that if your atom has close or fully occupied, then your ionization will be high. So that means if you have because what you have fully occupied, so it's hard to ionize. So basically, the first helium is fully occupied because this is also close to fully occupied. And the oxygen and so Ar is a noble gas. So the answer should be E. The answer should be E. Okay. For the if a strong ionized helium atom is unequal to force to emit a photon wavelength, and which of following approximate final level? Okay. So this is the hydrogen atom, hydrogen-like atoms. So your Bose theory tell you that this is the energy level of your helium atom, ionized helium atom. Okay. So what you have is that you start from unequal to 4 states. So your initial is, and then you emit a photon. So some photon, which is energy for this one. So basically, you will have this is EV. So what you have is your photon energy can be computed. Basically, is 2.5 EV. Basically, you can use this formula. This one divided by this, so it's close to 2.5. And you're okay. Okay. So what you need to we just need to solve that. Suppose the final is some NF squared, then basically the final energy will be the initial energy minus the photon you emit. Okay, and then solve NF. Okay, and then we can get NF is close to 3. Okay, so this is the answer. Okay, so which one? NF should be 3. So the answer should be A. Okay, 24. 41. 3p electrons found to be 3p s 3/2. Okay, so notation. This is the important notation you need to remember. Is Lj 2s plus 1. So 2s plus 1 here is 3. Call it spin has 1. And this is p, so L equals to 1. And then this is 3/2, means that J equals to 3/2. So the first theta is allowed to make an electric dipole transition to 2s. So now you see the delta L is difference. So you from L equal to 1 to L equal to 0. So this is allowed. B is allowed to make an electric dipole transition to P to the same level, which is false. B, because the selection rule tells you that the delta L cannot be zero. So B is not correct. Also C said the quantum number L equals to 3. No, quantum number L equals to 1. D, it has the quantum number J equals to L. J is not equal to L. E has exactly the same energy. It would be this level. Nobody knows. So the answer is A. Answer is A. Okay, 42. Light or wavelength 500 nanometers is incident on sodium, and you have 2.28 work function, and ask about what? The maximum kinetic. Okay, so the kinetic of the electron, just the energy of the light minus work function. So you have this standard formula divided by 5000. So this is the Armstrong 2.28. The answer is 2.0. Z.2 EV. 0.2 EV. Okay, so because this one is, let me see, this 124 over 50 is 102, so it's 2.48. So 2.48 minus 2.28 is 0.2 EV. So HV can be written as this one. I suggest that you remember this, and the units you need to use Armstrong. This is very important formula, very convenient formula you should remember. Okay, so the answer is 0.2 EV. 43. You have a line integral along a circle. Okay, line integral along a circle. So remember what we need to use is the Stokes formula. Okay, so your Stokes formula tell you that you can compute the currents. This is what's this? Nobody knows. We need them to compute. So partial x, partial y, partial z, y minus xz, I j k. So this 0, 0. Okay, so it's minus 2k. And then your area is basically the plane, plane on xy plane. So this is okay. Dx dy. So your answer is minus 2 times. Because I'll remember that. Because they didn't tell us the orientation. But fortunately, they are only positive. So what you need to know is just compute the magnitude. So what we get is minus 2a, minus 2 area. What we get is, where's the result? So minus 2 area. So remember this is minus 2. Okay. It should be somewhere. Oh, here. So it's minus 2 area. So it's, if we calculate the magnitude, so it's 2 times pi r squared. Very tired. So the answer is C. 44. Somebody tell you that the velocity is beta x minus n, and what's the acceleration? So acceleration is dv over dt, or we can write dv over dx over dt, which is v times dx over dv over dx. So this is v. So we have v times dv over dx beta minus n x to the minus n minus 1. So this is the answer. Unfortunately, there's no this answer. So we need to plug v equals beta x to the minus n into this. So we have minus beta n x equals times v, which is equals to minus beta square n x to the minus 2 n minus 1 power. Okay, so the answer is A. The A is exactly the same as our computation. Let me see. Okay. I think it's enough for today, and I will see you guys in the next video. Be sure to subscribe to my channel.